Hello everyone, welcome back to my YouTube channel. So on day one of Kubernetes series, today we are going to focus on Kubernetes pod. So this is the place where our actual applications run. So the container which we create, those containers run inside the pod. So let's understand in more details about pod. So what is a pod? So pod is the smallest and the most basic deployable unit that Kubernetes creates and manage. So this is a very small object which managed by Kubernetes. So you basically like whenever you create a container for your applications, like you are going to put your application code, binaries, libraries, runtimes, everything, then you cannot directly deploy that containers to a Kubernetes. Basically the containers will not run. So in Kubernetes that container sit inside the pod, and that pod, the job of pod is to run that particular containers. So in other words, we can say the container is your app in a box. So your application, like whatever the code is required, everything you have packed in a box, and that box you are going to hand over to a pod. So the pod is a home for a containers. So Kubernetes doesn't run containers directly. Instead, it puts them inside something called a pod. So in other words, pod is like a small virtual machine or virtual room where one or more containers can run or live. So it is the smallest unit in Kubernetes that can be managed by Kubernetes itself. So let's understand from one of the image. So suppose this is our application. This is the box where we have our application code, applications, binaries, dependencies, libraries. So everything we have packed inside these containers. Now Kubernetes cannot run directly these containers. To run these containers, Kubernetes use a pod. So you can see this particular box is a pod, and inside pod you have a containers. So now the question is, can we run multiple containers inside a pod? Yes, you can run multiple containers inside a pod, but there is a restrictions. You cannot run a same type of containers inside a single pod. So what does it mean basically? So you can run your application container inside a single pod, and along with you can do a help, you can use a helper containers. For example, if for this your application container, if it's required any kind of logging or maybe database data synchronizations, so for that you can run a containers. Suppose we have deployed a nginx web application as part of these containers. Now we cannot create another containers. Sorry, we can create another containers, but we cannot deploy the same nginx container inside a same pod. That will not work. So that is the limitations. So in most of the cases you will see a single pod can run only single containers, but there is a options you can run multiple containers, but that should not be a same type. So that you have to keep in mind. Okay, so this is what I have explained here. So the multiple containers we can run as we discussed. So for those containers, basically we called in terms of Kubernetes, we call as sidecar basically. Okay, so this is used when containers needs to share resources, communicate closely, and are managed as a single application unit. In that case, we can run definitely multiple containers inside a single pod. So this is the example I have given here. Okay, if you want to do a logging, like if you want to run another container inside a single pod, like for it to for logging purpose, for proxy, then you can use or you can deploy multiple containers inside a pod. Now there's a one highlight I have mentioned here. So pods are designed to be temporary. What does it mean? So the life cycle of pod is temporary. So it if you delete it, like all the data will be lost. So if a pod fails, Kubernetes what does, it will go and automatically create a new pod if you have defined a replicas. So replicas we will discuss in another videos. So just understand, replicas is the place where we define, okay, I want three numbers of replica, or three instance of my applications. So those things we define inside or under a replica. So what it does basically, so this is the desired state in terms of Kubernetes. Okay, I always want three instance of my applications. So what happens if something goes wrong with your application pod, Kubernetes automatically create a new pod for you, and it will delete the old pod which has some issues, or maybe it is stopped or it crashed. So it will automatically create a new pod for you. So that's why the pods are temporary in nature, so you have to keep in mind. So you should not never rely on your pod's IP address for or local storage. So if you want to use any kind of storage, like for example, if you want to save the application data, application configuration files, in that case you have to use another options, like you can go with persistent data volumes, or any mounted files you can use. So there are a lot of options which we will discuss in later in more details, but just keep in mind, pods are designed to be a temporary, like that they are designed. That's why they are the very smallest unit inside a Kubernetes. Okay, let's move to another slide. So why are pods important? So the very first thing is resource sharings. So all containers within a pod share the same network namespace and can share the storage volume. This simplifies the communications, like they can talk via the local host itself. They don't need any specific IP address for the communications, and they can share the data between themselves. So they are basically tightly coupled. So that's why, suppose if you are going to deploy your application inside a pod, and along with you want any other another containers, you can do that. But as I told you, that should not be a same type. So you can use, and why we use multiple containers if it's required. Ideally, in most of the cases, you will see in real time, generally we deploy a single containers inside in a single pod. Like basically one pod will have one container only. But in case if we have any such kind of requirements, we can do that. So the communication parts becomes very easy if we use multiple containers inside a single pods, because everything will be shared between both the containers, all the networking parts, storage parts. So it becomes quite easy. So simplified communication, so that this is what we have already discussed. Like they will not have they will basically use the same networking, same ports, so they can easily communicate. Co-location and co-schedulings. Suppose all the containers in a pod are always scheduled together on the same physical or virtual machines. So suppose you have scheduled something like, okay, I want to deploy the my both the containers in this single pod, and that pod should always run on a particular virtual machine or maybe a worker node. So whenever something goes wrong with that particular pod, Kubernetes automatically create a new pod with both the containers, and it will deploy in maybe another worker node. It is not mandatory, it will always deploy to a that particular node itself, but if you want a particular node for the deployment, you can do that as well. Okay, now the question is, so how many, like we will go and just create a pod and we will use our application? No, there are controllers who basically manage our pods. So the very most common and important controller we have here is deployment. Then another controller we have replica set. Then we have stateful sets. Then we have job, cron job, and daemon set. So these are the controllers which basically manage our application, or which generally manage our pods. So we will cover each of the controller in a separate video in a detailed manner. But for just now, for understanding, just assume, not assume basically, just keep in mind, for to manage our application pods we use controllers, and these are the controllers which are available as part of Kubernetes. Now the networking part. Suppose I have deployed my application in I have deployed my pod. Now how I will access my applications? Like, we cannot go to inside a pod and access our applications. Definitely we will use any client machine or external browser to access our machine. So for that we have a networking options which allow us to access our applications from our local systems or browser. So generally a Kubernetes use the flat network model. So the Kubernetes aims for a flat network where all the pods can communicate with each other directly, regardless of which node they are on, without the need of NAT. NAT is a network address translation. So this is generally used for private communication. So this is also not required, because the architecture or the concept behind Kubernetes networking is the flat network models. So if the pod are inside your worker nodes, like if you have two pods, they can communicate with each other. But if you want to access those pods from outside the your Kubernetes environment, in that case you have to use Kubernetes services and container network interface. The plugins basically we have like Calico, Flannel, Cilium. So these are the networking plugins we have. So with the help of these plugins we will implement a networking to allow our application to accessible from the outside the world. So again, the services part is again a very lengthy topic, and there are many services options we have, like cluster IP, we have then node port, load balancers, ingress, so a lot of services options we have. So we will discuss services in separate chapter, separate video series. So just for understanding, Kubernetes use a flat networking model. So the pod inside a Kubernetes environment can communicate with each other, but to access those applications outside the Kubernetes environment, we have options, like we can generally use a Kubernetes services to access our applications. Okay, now comes to a pod storage. So as I told you, the pods are designed to be a temporary. So if the pod goes crash, or maybe pod got deleted, in that case whatever the data you will have inside a pod, that will also gone, because Kubernetes always create a new pod. If the any one of the pod got crash, it will automatically create a new pod for you. So the storage part, the data basically whatever you have stored inside that pod, that will be lost. So to overcome this issue, we have multiple options in Kubernetes. Like you can use host path. So where basically you can mount a file system or a directory from your node system where actually your Kubernetes is running, and you can mount that host file system. You can mount a file path of your host machine to a pod. That is the one options. And you can also use a persistent volume or persistent volume claim for that. Like if you are using any cloud providers, for example, if you are using Azure, then you can use Azure storage. If you are using AWS, you can use EBS volumes. In Azure, we have managed it. So there are a lot of options available which you can use to keep your data safe. So you have to always, like in real-time scenario or in production levels, we don't rely on storage itself. We always use the external storage to store our data. So this is the plugin, or I would say add-on, container storage interfaces. Basically it is a driver which allow us to third-party storage volume to connect to our application pod inside the Kubernetes basically. So this is the storage solutions basically in Kubernetes we have. So we can add any of the cloud providers storage system we can attach in our Kubernetes. So that also we will cover in upcoming videos, but just want to give a quick overview about the pod storage here. Okay, now let me go to demonstration part. So what I will do, so first thing, let's verify our Kubernetes status. So our Kubernetes is running, so we can see all these control plane components are running fine. So what we will do basically, let me go and open my Visual Studio Code. So here I will go and create a sample, very basic pod file, and we will deploy our applications. Okay. So first thing, let me go and create a YAML file. These are the basically manifest which we create to deploy our applications. So let me give a name demo.yaml. You can put YML or you can also put YAML. So this is the blank file we have created. Now there are 4 objects which in most of the Kubernetes manifest you will see. So very first is API versions. So you can see I'm automatically getting these options. So these options I'm getting because I have installed a extension. So if I go to here extensions, so you can also install these extensions that will help you to write a YAML file as well. So you can go, so okay, let me quickly check which one you can use. So you have a YAML, you can use this one, and another you have Kubernetes support, maybe not this one. Let me check what is this one. So this extension for developing, building. Okay, so you can, I think, use this one as well. You can simply go and search for in extension like Kubernetes and you will get a lot of options. So you can download the extension in your local system. So this is the one which I'm just talking about, Kubernetes supports. So it will automatically tell you, okay, what next. So it will autofill your command basically. You can use this extension for in your local system for to writing a YAML file. Let me close this. Okay, let me go to my file system. So this is the API versions which we use, which is v1. Now kind. So kind here, what kind of resources you want to create. So I want to create a pod. So here you can see a lot of options we are getting here, but we are interested in at this stage on Kubernetes pod. So simply select a pod here. So this is the API versions, Kubernetes API versions, or schema basically we can say, and this is the kind, what kind of resource we are going to create. So if you simply click on, you will get a complete details as well about the object which we are going to use. And another one we have here is metadata. So if I simply type meta, you will see here I got a metadata. So here we can give a name for our this application. So let me give a name, my demo app. This is the very basic pod application of pod file basically we are going to create. As soon as we will move to later parts, we will try to enhance this manifest file. Okay, so the API version, kind, metadata, and then we have another important which is specifications. So you can see as I type specification, it will automatically enter 2 fields, containers and names. So that means under specification we define, okay, what we are going to achieve, specification of the desired behavior of the pod. So we want to first give a name of this container. So let me give a same name, my demo app. And now inside containers, this is the name we have given. Now what next? You have to provide a image here. So if I'll simply search here image, sorry, not this one. So we are going to use nginx image basically. So let me type it nginx, and we are going to use latest. if you want to install any any specific version, you can, instead of latest, you can mention that version. So this is the very simple YAML file which we have created to deploy nginx web applications. So this is the image we are going to use nginx, and we are going to use, this is from the global docker registry, a docker hub basically. So it will automatically go and fetch. Now if you want to use your custom images, so for that you use a docker. So for that you write a docker file and you build that docker file, and from once you build the docker file, from after building, basically it will generate a docker image. So you can specify that image here. So we are not going with docker. If you are learning Kubernetes, I assume you definitely know at least beginner level of dockers, like how to write docker file, how to build a docker file, how to push a docker image to a registry. So this is the very simple concepts. Okay, so now let me go and save this file. So now what I will do, I will use a kubectl command. So kubectl is a utility which you should have in your local system to interact with Kubernetes cluster. So I will type here Kubernetes apply -f, and here I will give a file name which is demo.yaml file. So what we are going to use kubectl, and this is the apply command. We want to apply kubectl on this particular file. So what it will does in background, so it will go and interact with Kube API servers, and from the Kube API servers the instruction will go to a worker nodes. Then our application or our pod will be deployed on a worker node. So let me go and hit enter. Okay, so we got a error from a server, bad request, pod in a version b0 cannot be handled as a pod. Okay, unknown field, specification and image. So maybe here you have to keep one more thing in mind, indentation is very important in Kubernetes. If you miss any spaces here, you will not, your file like whenever you run a kubectl command, it will fail. Okay, so now let me save this file and let me enter. We are getting this warning because we have not specified any resources. Resources again we will discuss in details, but resources are something like if we want to specify, okay, this pod will use this much memory or this much CPU, so those details also we can specify in YAML file. So I'm not going on that because this is just a starting. So let me go and run this file again. Okay, so now we got a message, pod, this is the pod name, is created successfully. Okay, so to verify it, again we have a command called kubectl get and pod. So you can see we get our pod, this is the name of our pod, my demo app, and the status you can see 1 out of 1. What does it mean basically? So we have requested only single pod, and out of single pod its status is 1, like 1 pod is running state. If you see here 0, it means 0/1, it means 0 pod is running out of 1. Okay, so this is the status we are seeing running, and the age we can see, okay, last 15 seconds my application pod is running. Okay, so now the question is how we will access our nginx application which we have deployed as part of this particular pod. So to access our applications we generally use services. So services we have not covered in this. So to verify, just verify our application pod which we have deployed is working or not. So what we will do, we will use port forwarding option here. So let me type a command kubectl port forward and my pod name which is my demo app, and we want this port forward to my local system, like my local desktop. So on local system I want port, for example 4 times 9s, and here, so this is the node port. So on this port we will access our application from our local systems, and this port basically route the traffic to the container port. So nginx generally run on port 80, so I have not here specify a container port. If you want, you can simply search here for container, not here. I think we can simply use ports. Okay, yeah, ports, container ports, and you can specify here port 80. If the port, if you are not sure about the port, or if you want to use a customized port, you can do, and like you can use like this. So as we know, the nginx by default run on port 80, so that's why I have not specified this part, but if you want, you can use it. So now let me put here 80. Okay, so now you can see the forwarding from localhost to 4 times 9. So if I'll go and open my browser and I will search here localhost, let me search here. So now you can see we are able to access our nginx application homepage. It means whatever the image we have deployed as part, or whatever the applications we have deployed in a Kubernetes pod, it's working fine. As soon as I stop this command here, if I let me stop it, now I will not able to access my applications. So that's why the port forwarding is stopped. So that's why we use a services, which we will discuss in upcoming videos. Just want to show you whatever the deployment we did as part of nginx image, it's working fine. Now if you want to verify a logs for our, like in case if the running status is showing failed, or maybe another error you are getting, then you can troubleshoot it. So simply you will type a command kubectl. You can use logs as well, and you can define a pod name which was my demo app. So you will see a lot of details here. Okay, so you can see, we can see a lot of details about pods, but still we are not able to see a majority of details. So for that, what you can do, you can clear this, you can use a command called describe, and kubectl describe pod, and here pod name. So my pod name is my demo app. So now here you can see a lot of options, a lot of basically details about your pod. So you can see all the events as well. So if I first go down, so in the event section you can see what it does. So first it go and schedule the pod. So this is the job of kube scheduler. Then it go and pull the nginx image from the public repositories Docker Hub. Then it successfully pulled the image, then it created the container with this name, and it started the container. So all the events, what is happened in background, everything we can see here. And you can see a volume details as well. And here like a lot of the details, basically you can see a started date and times, image, you can see it use Docker container, sorry, so basically you can see a lot of details here, and you can see also pod IP address also. So that we have discussed, like we should not depend on pod IP address, because as soon as we delete this pod, again new pod will be created and it will have an again new IP address. So you can see a lot of details in case if you face any issues during your pod creation, like if it failed, or maybe it went to a crash loopback state. So all those issues, all those things, you can simply track it, like fix it with the help of kubectl describe pod commands. You can see what actually happened, and you can go and fix that particular error. So I hope it's clear. We have discussed a lot of things about pod, and a lot of things we have left it to, which we will discuss in upcoming video series. Majorly part services we have skipped. We have just simply go and had the overview, and we have skipped the controller part. So those we will see in a separate videos, because in single video it is not possible to cover all the topics, and people get bored as well. So let's keep, like, each topic, I just want to keep everything in a separate manner, so it will be easy for you, or easy for the newcomers who is going to learn Kubernetes as well. So that's all for today. I hope it's clear. In case of any issues, definitely you can ping me over comments. As soon as I show your comments, I will reply as soon as possible. So that's all. See you in next video. Thank you so much.